Hello, everyone. Welcome. I'm going to start with this first, which states that please do not purchase Salesforce based on anything that you see here today, but rather on what is currently available. My name is Sarah, and I'm a Salesforce developer at 4C. We're a consulting company based in Belgium with offices in the UK, Denmark, France, Morocco, and the United Emirates. Can I please have a show of hands of how many of you here like automated tests? Oh, yeah, most of you do. And if there are people who do not like writing automated tests, please stick with me till the end of this session, because there might be something for you too. And I'll actually start with that. I'll start with how I started enjoying writing automated tests. That was while writing Apex triggers. Every time I had to write an Apex trigger on create, I had to go to the Salesforce user interface very often to create records, and I would end up with red messages saying that a validation rule just failed or I forgot a required field. And that annoyed me a little bit, so I started doing test-driven development. I would write a script first that would create the record for me, and then check if the trigger was doing what it was supposed to. Initially, this would fail, and I would keep on working on my trigger until the test would pass. I ended up this way with really good automated tests on which I could rely on. And I was also saving time because I didn't need to create records on the Salesforce UI anymore. But not only me, but other members of my team could also benefit from these triggers, from these automated tests, because when they were trying to integrate their functionality with mine, it was easier and they would get a reply much faster if they broke something or not. But I don't always do automated tests. Sometimes, especially when I am working on something visual, like a visual force or a lightning component, I'm mostly focused on the visual part, so I keep on working on the controller and the visual component. And I leave tests for last. And it's here where I am under time pressure and I meet what is called the Goodhart's law. This law states that when a measure, code coverage, becomes a target, under time pressure, my only target is 75% code coverage, then this measure ceases to be a good measure. And this is where most developers create tests that are partially asserting, that are weak tests, or sometimes they don't even assert anything at all. But Goodhart's law also says that when we game a coverage, a measure like this, then a solution would be creating a new measure. And that's what we can achieve through mutation testing. Mutation testing is a type of software testing where we insert bugs into the source code, and then we see how good our tests into finding these bugs. I am going to demonstrate this theoretically through 5 steps. The first one being the generation of the mutants. A mutant is a copy of your code with a small change in it. I'll show this with this small script. I'm trying to fetch the account with the highest balance, and if this balance is above 250K, then I'm going to give a fancy gift to my client. A mutant would look like this. You can see highlighted in yellow, and was changed into an OR. I could create a mutant also by changing bigger than to bigger than equal. Or we could have value mutations where it would go through your code, find magical numbers, and then substitute them with another random number. What it would do in this situation is that I will no longer receive the account with the highest balance, but the second account with the highest balance. More complex mutants can be created by mutating statements. You can either change the order of the statements, or you can completely remove a function call. With this table, I'd like to demonstrate two features of mutation testing. The first one, you might have been wondering while looking at this code, why have I chosen to make the solution like this? The SQL query could have done a lot more, but I wanted to have more places in the code where I could create mutants. So I needed more of these spots to mutate. And that's what I'm trying to show here in blue, that the number of mutants is not dependent on the lines of code, but rather on these mutant operators that you can create mutants upon. And in red, it also shows that there will always be a lot of mutants. And if that sounds like it's a bad news, it actually is not, because the tool, we can create automated tools to generate these mutants, and you'll have all 300 mutants in about 2 seconds. The core of mutation testing is actually running the tests and now see how good are these tests in finding these bugs, so the mutants that we just generated. To do that, I will change the body of the class with the body of the mutant. Here is just a part of the script, and I will run the test. If the test fails, we say that the mutant was killed. When a mutant is killed, this is how the test shows us that it can find this bug. And this is the happy flow of mutation testing. A killed mutant would also be generated by changing true into false. But sometimes, like when I remove this statement call, the test will pass. We say that the mutant survived, and this is when we have a problem, because the test is not capable of finding such bugs. Another survived mutant would be changing bigger than to bigger than equal. So I went step by step with you on how we change the body of the class with the body of the mutant and run the test. But you don't need to be there while this is happening. This is also something that can be automated. And at the end, you'll receive a table of results about which of the mutants survived and which ones were killed. You can also receive a mutation score, which is expressed in percentage, the number of killed mutants over the total number of mutants. We had 4 mutants and we killed 2 of them, so we are at a score of 50%, which in my opinion, it's not a really good score. So I will go through the fix phase instead of deploying my code into the next org, into the pipeline. To do that, I go through the survived mutants, I choose one of them, and now I'm going to try to fix that. Because this was a mutation on comparison, I know that to fix this, I need to do boundary testing. I need to test on the threshold value and on the bigger and smaller value. Ideally, for an integer, that would be plus minus 1, and if you were using double numbers, you just add more zeros in front of the 1. I create more tests, or I change existing tests to do this. And now I run the tests again to see if they're capable of killing the mutants. And once I see that now I have 75% mutation score, I think that is a good mutation score, so I would deploy my code. As I mentioned at the beginning, the benefit that I had from writing good automated tests was that it would save me time. And you would save more time the sooner you have good automated tests, because you will not need to do a lot of manual tests into the other orgs into the pipeline. So we suggest that mutation testing should also happen as soon as you write your automated tests, because this way you have, the soon as possible, the best automated tests you can have. And now it's time for a demo. I would like to thank my colleagues who have helped me to create this tool that I'm going to demonstrate to you, especially Quinton. He'll probably see this in 2 weeks from now. Okay, the demo. It's a video because I didn't have a lot of time to do the complete flow. So the tool is a Heroku application where users need to log in with their Salesforce credentials. I'm here connecting with my Salesforce, with my 4C account. And the first message that I received says that I don't have any sandboxes yet. I need to connect to a sandbox or to a developer org. I'm connecting to a developer org so that I can do mutation testing into that developer org rather than on production. Once I'm connected, I can now create bundles. Think of bundles as a project. Normally, in a project, you have created some tests and you would like to know how good are these tests. So what we ask in a bundle is to show us the tests that you would like to have a response to, and also the classes that this test is calling, so that we can mutate these classes to see how good the test is performing. After I save the bundle, I can always go back to the bundle tab to either edit the bundle or create new ones. And on the test tab, now tests here is run a mutation testing. So I just choose a bundle, and as soon as I click save, a mutation testing starts. It fetches the code from the org, creates 3 mutants. It's changing the body to the body of the mutant, running the test, and I can see that the 3rd mutant, where end was changed into an or, is actually a survived mutant, so the test is passing. And I'll have to now go into my IDE or developer console to change the test so that I can kill this, this final surviving mutant. As I said during the demonstration, I am going to create a test on the value, a smaller value, and also on a larger value. I added an extra test with 2 accounts, where the second one has a bigger balance. And I make sure that that one has the gift. If I lower the balance, then I expect the first account to now have the gift. And it's good practice to save and run the test while you're still in your IDE. If with coverage, one way to cheat was by creating tests that always succeed. In mutation testing, you could create tests that always fail. Our tool checks for that, but you wouldn't want to create a testing fail here and then go to the tool, and the tool gives you an error, and then you'll have to come back to the IDE to fix it. Now I go back to and rerun the first test, which has the same bundle. And I expect that this time the 3rd mutant is also killed. And so it is. If I go into the tests page, I can see that now I have a score of 100%, and that's the ideal score. So this project is ready for deploy. I would like to conclude with 3 situations where you could use mutation testing. So far, I've been talking from my perspective as a developer, how it helps me become more confident on these automated tests that I have written under time pressure. But it could also be useful for, let's say, managers, for somebody who doesn't really need to have code knowledge and go into your tests to see how good they are. The mutation score already shows something about how good and how much you can depend on those tests. And this is very useful when it comes to new projects, and you need to assess the risk of working into projects that have already a big existing code base. On the other side, at the end of a project, for us as consultants, it's very important to create projects with high quality. And the mutation score is just one other metric to show how good the project that we are delivering is. Thank you very much for listening and being here today. The tool is still under development. If you are interested, you can either scan the QR code, and it will take you to a survey where you just need to input your email and your name. And there's a survey immediately after asking you for the email. If you want, you can just, if you don't want to answer, you can just skip all of that. The email is enough. And if you think, if you would want to have access to the tool while it's still under development, you can also just write me on my LinkedIn or email. Yeah. Thank you very much. If you have any questions, I'll be here.